Welcome back to this channel for solutions of practice problems for actuarial exams P, FM, MLC, and MFE, and hopefully more in the future. You have some websites here that give you links to my work. I use this redirect service, smarturl.it. You can find information about me at smarturl.it/Jedi. If you would like to find information about the Actuarial program at Illinois State University, where I direct the program, you can go to smarturl.it/actuary. My manual for exam P, which we will talk about today, is at smarturl.it/btdt-p. BTDT is what I suggest as the method for studying for you for the actuarial exam. It stands for been there, done that. When you take the exam, when you look at any problem on the exam, you should be able to say, been there, done that. If you haven't done many problems like that, if you don't know what to do immediately, there is no time on the exam for thinking. Thinking is the last resort of the unprepared. All of the thinking should be done before the exam. So here is the problem for today. We have order statistics from a continuous probability distribution with a finite mean, median, m, and variance sigma squared. They are x1 in parentheses x2 and so on. So these are you have a random sample and you put it in order. Basically, that's what it is. Let Fi be the cumulative distribution function of a standard normal distribution. That's a standard notation as well. Which of the following is the best approximation of the probability that 220th piece of this collection of order statistics, so the 220th order statistic, is less than or equal to m, the median of the distribution, using the central limit theorem. You have 5 choices here. This is really a very nice problem, because what we have here is this, that the probability that 220th order statistic is less than or equal to something is the probability that exactly j random sample elements are less than or equal to m, and all the other ones are not less than or equal to m. Okay. But being less than or equal to m, what is the probability of that? Well, it's f sub x of m, the cumulative distribution function, evaluated m, but m is the median, so this is just 1/2. And what is the probability of not being less than or equal to m? It's 1 minus f sub x of m, but m is the median, so f sub x of m is 1/2. 1 minus 1/2 is also 1/2. So what we have here is something like this. We do 400 times, we look at every piece of this, we do 400 experiments in a sense. 400 times we look at every piece of this random sample and we check if it's less than the median or greater than the median. And we can think about it like this. If it's less than the median, less than or equal to the median, then it's a success, and if it's greater than the median, it's a failure. So what we are describing here is the probability that a binomial random variable with parameters n equal to 400, p equal to 0.5, has at least 220 successes. And the mean of that binomial distribution is 200, and the variance of it is 100. If we denote it by n, then the probability that n has at least 200, n is greater than or equal to 220, is the probability that n is greater than 219.5 through the continuity correction, because n is discrete and the continuous normal distribution is continuous. And then the mean of it is 100, variance is 200, mean is 200, variance is 100, so the square root of the variance, or the standard deviation, is 10. So this is the same as probability that n minus 200 over 10, which is approximately standard normal, is greater than 219.5 minus 200 divided by 10, but that's just 1.95. So we're looking at the probability that a standard normal random variable is greater than 1.95, which is 1 minus the cumulative distribution function of the standard normal evaluated at 1.95. From the table, that's 0.9744, so the answer is 0.0256. Now let's just take a look again at this method of solution. So notice this, that we are starting from x 220 being less than or equal to m. Okay. What does this mean? It doesn't mean that exactly 220 pieces of the random sample are less than or equal to m. It means that the 220th order statistic is less than or equal to m. But it's entirely possible that the later ones could be also less than or equal to m. The only thing that we must have is that we have the first 220 order statistic less than or equal to m, because every single previous one has to be less than this one, less than or equal to this one. Okay? That's one observation. That's why we're saying it's the sum from j equal to 220 to 400 of these probabilities that are exactly j random sample elements are less than or equal to m. Right? So it could be 220, 221, 220. The higher ones can be less than or equal to m, no problem. The smaller ones cannot be greater than m. That's the point here. The second thing is this counting of successes. Okay? At least 220 successes. What's a success? A success is a piece of the random sample is less than or equal to m. Okay? X 220, in parentheses, being less than or equal to m means that we have at least 220 successes. That all the pieces up to 220 are less than or equal to m, and x 220 is less than or equal to m. That's the minimum requirement. But it could be also that x 221, 222, and so on, up to 400 are less than or equal to m. That's why we added up. But in terms of the binomial distribution, that's simply having 220, 221, 220, and so on, up to 400 successes. That's why this is the same as probability that n is greater than or equal to 220. That's important in setting this up. I hope this makes sense. Please remember that this is copyrighted material. Good luck on your exam. Good luck studying, and good luck on the exam. And as I always say, you should study so hard that you don't need luck. But good luck anyway.